Hi guys, so we are going to be working on lesson 7.6 this time, and it is called fraction multiplication. It is on page 327 in your book. I'm just going to start going through the unlock the problem part. All right, so our first problem is, it says, Sasha has 3/5 of a scarf left to knit. If she finishes half of that today, 1/2, how much of the scarf will Sasha knit today? So we have two questions off to the side to begin with. How much of the scarf does Sasha have left to knit? And it tells us that it tells us straight out there in the first sentence. If you look at it, it says, Sasha has 3/5 of a scarf left to knit. So that's the answer to our question. How much does she have left to knit? She has 3/5. So that's for our first dot. These are the dots. They're over in the little green box that's off to the side. Second dot says, of the fraction that is left, how much will she finish today? So let's go back and read again. If she finishes half of that today, so she's going to finish half. So we're going to come over here, and write down a half on the line. Okay, so now we have the model. You already have this model in your book. And it says we are going to shade 3/5 of this model yellow. Just a second.
Okay.
Sorry about that. Okay, so we have, if we look at this, we can see that there is 1, 2, 3, 4, 5 slots. It wants us to do 3/5 of the slots. So we are going to color 3 of them in yellow. This is the yellow. I hope it shows up. I don't know why they want us to do it in yellow. 1, 2, 3. So we have 3 of them shaded in yellow. We are then going to draw a horizontal line across. Now, the reason we're drawing this is because it wants us to deal with that 1/2 that we have going on there, and a half is cutting it in half, just straight across, cutting it into 2 parts. So we have a top part and a bottom part, 1, 2 parts. That's all that we're doing. Then we are supposed to shade half of that blue, which, let me get a lighter blue. I think that might work a bit better, because if I shade it right now, we're never going to be able to see any of it. You can do this in crayon or colored pencil or something like that in your own book. I'm using marker because marker shows up better. So I'm going to go across like that, and I'm shading half. So I'm stopping at the line that we have there. And we can see through it because I didn't lighten up, so yay. We are then going to count the sections that are shaded in. So I have 1, 2, 3 sections that are shaded in. And then I need to put it over how many sections I have now. I now have a lot more sections than I started with. I no longer have 5 sections. I have a lot more. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections. So I actually end up with 3/10. And then I need to write down that point right there is 1/2 times 3/5 is equal to 3/10. Okay, we are then going to compare the numerator and denominator of the product to the numerator and denominator of the factors.
What?
Describe what you notice.
What are you looking at?
What I see Well, what I see is that the numerator is the same for the one part. For one of the fractions. The denominator is larger. But the thing is, overall, the entire thing is smaller. The denominator is larger. That's all true. That answers the question. That's what we noticed, I suppose. Okay, if you don't have a copy down yet, pause it, copy down what you need to, unpause it when you have it copied down. I'm going to move on to the next one, okay? Okay, so another way. Now I'm at the bottom of the page, all right? And it says you can multiply the fractions without using a model, which is how we normally end up doing it. So I have 1/2 times 3/5, which is the same as, now remember, we were doing this with just multiplying the numerators by each other. And so I had put the bar there and I said, well, what numbers go on the top? And it was 1 times the 3 because the 1 and the 3 start on the top. So we're going to put it on the top. Remember that? Okay, so what we did at the top, we can do the same thing to the bottom. It always works that way with fractions. Everything that you do to the top, you do to the bottom as well. That's just the fraction thing. So since I could multiply the top together like that, that means that I can also multiply the bottom together like that. So I can take this 2 and the 5 and put them there just like that as well. And then I have two multiplication problems. I have a top multiplication problem and I have a bottom multiplication problem. So if you need to, you can get out the multiplication chart that you have. It's in the back of your, oh bother, what is that called? Your student planner. Or if you don't have one of those, they have so many of them available online, it's not even funny. And you can sit there and you can just download one of them. That's okay. So we have 1 times 3, which is 3, and 2 times 5, which is 10. And that ends up giving us the same thing. Now the blank spots that are at the bottom of the page, you are supposed to have filled in with the 3 and the 5 to fill in the rest of the multiplication across. And then at the very, very bottom, you are supposed to have filled in with the 3/10. And then, so Sasha will knit at the very, very bottom of the page, 3/10 of a scarf today. Next page. Pause if you need to stop so that you can write it down. Okay, so so I don't waste paper, I'm just going to write the next page at the bottom of this one. So I'm going to put this line here. This means I'm on page 328 below this. So now I have 4 times 5/12. Okay, so it's talking about, it wants us to remember that any whole number we have always has a 1 underneath it. So 4/1 times 5/12. This is true all the time. It means that I have 4 full parts and each part is only 1 part. So the entire thing is only 1. The entire circle is just the 1. Which means it now lines up exactly the same way that the one that we just did lines up. Because I have that 1 underneath it. And you can always put a 1 under any whole number you're given, okay? Any whole number, you can put a 1 underneath it. It's perfectly fine. It's kind of an invisible 1 that's there. It's always there. Okay, so when we rewrite this problem, so I'm going to go down to the next the next line of it, when we rewrite it, it ends up looking like this. It says equals 4 times the 5, because the 5 is on the top, over 1, which is on the bottom, times 12, which is on the bottom, which equals out to 4 times 5 is 20. 1 times 12 is 12. Then I'm looking at that and I'm going, ooh, I have a 20 on top of a 12. Ay, 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 ay. Why would I have a 20 on top of a 12? Oh my goodness. Okay, so now I need to fix this. So the first thing it wants us to do is it wants us to simplify this. So we are going to rewrite this down here as the 20 over the 12. Okay, so we're just putting our fraction right there down to here. And then it gives us the division sign. So it wants us to simplify this first. It wants us to go, well, what's the biggest number I can take out of both of these? Now, it only wants you to take it out the one time. We would normally take it out the 2 times because there's actually 2 2's that we can take out of this. But because of the way that they have it set up, we're only going to take out the 1 time with the 4. Okay, it's an even number, so you'd be able to take out a 2, but then you would get another even number and you'd end up having to take out another 2. So it's a 4 that we can take out of it. So I'm going to put down divided by 4. Whatever you do to the top, you have to do to the bottom. That's one of the rules, remember. And then we have this equaling out to 20 divided by 4 is 5. 12 divided by 4 is 3. That hasn't really helped our problem with having a bigger number on the top, though. But the only way to do that, we did do this last time too, is to divide that out. So I'm going to go over here and I'm going to divide that out. I'm going to put the 3 into the 5. Okay? I'm going to put the 3 into the 5. Now, how many times does 3 go into 5? Well, if I have 5, I can take 3 out, and I'm left with 2. So I can only take it out 1 time. 1 times 3 is 3. 5 minus 3 is 2. I am left with that 2. I cannot take another 3 out of 2. So I have to put it back up here, 2 over 3. So now I have 5/3, which is equal to the same as 1 2/3. There we go. And then we end up with, at the very bottom of the page, it says, let me move this up a little. It says 4 times 5/12 is equal to our 5/3. That's the first one. Or 1 2/3. That's the second one. So those are our 2 blanks. If you need more time to write it down, pause. I'm going to move on to the next thing. I'm going to move on to the try this at the bottom. Okay? All right. Moving on to the try this at the bottom. Oh, it is now giving us a letter. All right, so it's just a letter. We don't need to worry about it. It's a number. We don't know what the number is yet. That's all that a letter means. And so we just need to figure out a way to write, and it even tells us what it, okay. Let me just write this down first. So it says C times 4/5. That's our problem. It then tells us that C is equal to 2 over 2. So when I said that C was a letter, we just didn't know what the number was for it yet. It actually tells us what the number is for it, which means I can sit there and I can take that 2 over 2 and just put it in place of the C, and we're good. what is another way to write the value of C? Okay, so this is where they think they're being tricky. Remember how we could, you notice how both of those numbers are exactly the same. If you divide a number by itself, what do you get? So 2 divided by 2, that's going to give us a 1. Anytime you divide a number by itself, you always get 1. Every single time. I don't care if it's 6,894 divided by 6,894, you will still get a 1 every single time. And yes, the ridiculous number you're thinking of will work too. So what happens whenever you multiply anything by 1? Anything by 1. 2 times 1 is 2, right. 6 times 1 is 6, right. 2,894 times 1 is 2,894. See, anything times 1 is always itself. So for the second one, for the second dot, first dot was the 1. Second dot is you get the number. Yeah, you get the number. What happens when you multiply a whole number by 1? You get the number. Yeah. Okay, so we are going to go over to this. I know that it already had us figure out that 2 over 2 was 1, but in the problem, it's going to force us to use what it gave us that C was equal to, because it has that fraction line there, so we're just going to have to deal with that. And so in the third point, what it wants is for us to write down that we're going to replace the C inside the expression with 2 over 2. That's what it wants us to write down. I know it's a little bizarre, but that's what we're going to do. So what we need to do now is go over to the side of your book. So you have all of the blank spaces off on the side right there. I'm looking at right here. You have all of those. That's what we're going to be working on right now. Okay, so let me put this back up here. I'm completely and totally messed up where I am. All right. So what we start with is the first thing that it gives us is, no, not the brown. I already used the brown. Let's use this. Times the 4/5. Sorry, my dog is freaking out about my daughter moving her chair in her bedroom. Okay, so what we have to start with is something that looks like this. Times the 4/5. And what they want us to put into it is this. They want us to take that 2 over 2 and put it into there. So we now have 2 over 2 times 4/5. We then come down here and we set up the problem just like we've been setting it up before, where we put all the stuff that was on the top, all the stuff that was on the bottom, and we're just going to work through it. So we have 2 times 4 over 2 times 5. Okay, so we now have 2 times 4, which is 8. And 2 times 5, which is 10. So I now have an 8 over 10. We are then going to drop that 8/10, because that is our current answer, down to the next line. So we're going to rewrite that again. Everything that's in purple you're writing. And we are then going to divide something out of that. What can I take out of 8/10? Well, they're both even numbers. And if it's an even number, remember our choices are 2, 3, or 5. So if you can't get to it by counting by fives, you can't do it. Half the numbers in the world, you can divide by 2. So let's try dividing by 2. If I divide 8 by 2, so 8 divided by 2 gives me 4. And 10 divided by 2 gives me 5. So I end up with 4/5 as my answer. So multiply the numerators, multiply the denominators. What do you notice about the product? Okay, so our product, we ended up with 4/5. We look up here, we started with 4/5. So our product is exactly the same. So down here, the last one, what do you notice about the product? Our product is the same as one of our factors. Our product is the same as one of our factors. Okay, so when we multiply c times 4/5 is equal to, it's asking what the entire problem is equal to. So we're just going to write down our 4/5 again. Is equal to 4/5 when c is equal to 2/2, because we just solved for that. Okay, so line of reasoning, bottom of the page. Will you get the same result if you multiply 4/5 by any fraction where the numerator and denominator are the same? So remember what we said, numerator and denominator are the same. That means it is actually equal to 1. So if you multiply something by 1, if we multiply the 4/5 by 1, will we ever get anything other than 4/5? No, we won't. So that's what they want us to write down here. They want us to write down that we're never going to get anything other than 4/5. So will you get the same result? Yes, I will always get 4/5. I will always get 4/5 because, other in another room. Okay, let me. I'm going to shift this off to the side because any number over itself equals 1. Okay, sorry. So, yes, I will always get 4/5 because any number over itself equals 1. If you need time to copy that down, and I'm sure you do, pause the video, copy down whatever you need to copy down. I'm going to be moving on to the next page. Okay, next page. We have, we're going to do some of the share and show ones together, and then I'll leave you to try to do it yourself. I think you can do it. You should be able to do this. Remember your times tables. You can look up your times tables. Okay, I'm not going to get on your case about that. So we have, to start with, we have number 1, 6 times 3/8. Okay, so they rewrote it as 6/1 times 3/8, which will be the 6 times the 3, 6 times 3, which is 18, over 1 times 8, which is 8. Now, 18 over 8. Well, we can't exactly put it down like that. We need to talk about it a little more. Can we take anything out of it? Remember, our choices are 2, 3, and 5. I can't take out a 5. It needs to end with a 0 or a 5 if I'm going to take out a 5. I could take a 3 out of the 18, but I can't take a 3 out of the 8. So, but I can take out a 2. So if I go 18 over 8, and then I divide the top by 2, I divide the bottom by 2, I get 18 divided by 2, which is 9, over 8 divided by 2, which is 4. So I now have 9 over 4. 4 goes into 9. Let's see, how many times does 4 go into 9? 4 times something is a little less than 9. Go with the 2, because 4 times 2 is 8. And 9 minus 8 is 1. We bring the 1 up there. We put the 4 underneath it. So it is equal to 2 and 1/4. Let's do number 2. We have 3/8 times 8/9. So we do 3 times 8, going straight across, 3 times 8, which is 24, over 8 times 9, straight across, which is 72. All right, once again, we have to divide something out of this. We're going to divide out a 2. I can sit there and I can do my division, and I know that 24 divided by 2 is going to give me 12. I know 72 divided by 2 is going to give me 36. So I'm now left with 12 over 36. I will be back in just a second. Okay, so I'm back. We have our 12 over 36, which is still not small enough. So let's go ahead and try to take out another 2. See what we can do with that. 12 divided by 2 is 6. 36 divided by 2. Well, I know that that one is 18. And I am still left with having to take more stuff out of this. Isn't it so much fun? So we get to take out another 2. Da, 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 da. 6 divided by 2 is 3. 18 divided by 2 is 9. And now I'm at 3/9. Well, those are both odd numbers. I can't take a 2 out of them. But there's another number I can take out of them. Remember, we got 2, 3, and 5. I can take out a 3. So 3 divided by 3, remember anything divided by itself, we've been working on that today. Anything divided by itself is a 1, and 9 divided by 3 is 3. So after all of that, we are down to 3/8 times 8/9 is equal to 1/3. And yes, I have done longer problems than that before, trying to simplify them. Okay, problem number 3. We have 2/3 times 27. Now, the reason why I wrote the 27 up there, in your book it has the 27 in the middle, but we need to remember, underneath every single whole number, we have that invisible 1. So we are going to add that 1 there, just so that we have everybody in order and in the right place. So we know where everybody is. Okay, so first thing we need to do is multiply the top. So I have a 2 times a 27. Oh, good heavens. All right, let's figure out what 2 times 27 is. 27 times 2, so I'm going to go 2 times 7, which is 14. And 2 times 2, which is 4, plus the 1, 5. So we have 54 over 3. Oh, sorry. We needed to do the 3 times 1. That's how we got the 3. Okay. Now this is an improper fraction, so we need to divide it. 3 into 54. Okay. Well, since our first question is going to be, is the 5 large enough for us to take a 3 out of? Yes, it is. So we're going to take a 3 out of it. So we're going to go 1. 5 minus 3 is 2. Bring down the 4. 3 times something is 24. Do you remember what it is? 3 times 8 is 24. So we have a 24 minus 24, which is 0. So our actual answer is just 18. And I am going to, all right, let me see. I'm going to, yeah, I guess I'll circle these. So that's problems numbers 1 through 3. I think, oh, good golly, you've been working on this for a very long time. I think you understand what it is that we're doing. If you don't, leave me a message and I'll help out with the, I'll put up some more examples. I'm not doing the entire thing with you, okay? So I know there are some of you who will sit here and say, but I don't understand this one and this one and this. So I will do some more examples if we need more help, but between the examples on the other page and these examples, I think you should be okay. All right, see you later, guys. Bye.